In the last video, we briefly discussed restricted values and the procedure for solving a rational equation. So we're going to jump right into rational equations that lead to linear equations in this video. On example 2, we want to solve the following rational equations and be sure to disregard extraneous solutions. So on our first example here, we want to begin by identifying the restricted value. The restricted value is the value of x, which makes the denominator 0. So I'm going to look at the factor x minus 4. If I set that equal to 0 and solve for x, we would find the restricted value x equals 4. So let's make a note of that. The restricted value is x equals 4. And I'm going to remind us we cannot, we'll say x cannot be equal to 4. So if I solve the equation and I get x equals 4, that's not going to balance the original equation because it would create a 0 in the denominator or an undefined rational expression. So with that in mind, we're going to solve this by clearing the fraction using the LCD, lowest common denominator. So because we only have one fraction in the denominator, our lowest common denominator is the binomial factor x minus 4. I want to apply this to every term in the fraction. Now, on the left side, we just have an ordinary rational expression, 5x plus 1 over x minus 4. So I'm going to multiply by the LCD expressed as a fraction. So I'm going to write it over 1, just to be clear how it interacts with our original fraction. Also, if you have multiple terms in your numerator or denominator, oftentimes it's helpful to insert a set of parentheses to group your terms together. Now, over here on the right side, I just have the constant 6, so I'm going to express the LCD as x minus 4. Once we've multiplied through by the lowest common denominator, notice the benefit of that now is that the denominator on the left side cancels. What remains is just the expression 5x plus 1. Since it doesn't have any other factors, I can go ahead and drop parentheses there. And let's be efficient on the right side and go ahead and distribute our 6. So we end up with 6x minus 24. So we started with a rational equation. Now we've transformed it into a linear equation. Remember, we know this is a linear equation because the highest exponent on x that I can find is 1. That tells me lots of important information. Number 1, I can anticipate one solution. And number 2, I can solve it by isolating x. So let's collect our variable terms on the left. I'm going to subtract 6x from both sides and collect our constant terms on the right. So subtract 1 from both sides. This leaves us with the equation negative x equals negative 25. Dividing both sides by negative 1, we have our apparent solution x equals 25. Now, the good news is we didn't obtain the restricted value, so we don't have to worry about that being extraneous, but we do want to be diligent and check our work. So I'm just going to use our calculator to verify our solution. So I'm going to type in the original numerator, but replace the x with our solution 25. So in the numerator, we have 5 times 25 plus 1, and in the denominator, we have 25 minus 4. This returns a value of 6. We had a 6 on the right side of the equation, so we know we have a balanced equation. So we come up with one unique solution for this rational equation, that is x equals 25. Now, we did do a similar method in section 2.1, solving linear equations that had fractions. Again, the difference there is that our lowest common denominator was a constant, whereas here our LCD contains a variable. Let's try example B. This one's a little more complicated. In order to identify our restricted values, we need to be able to look at the individual factors of all of the denominators present. So it would be helpful on the right side to go ahead and factor this quadratic denominator. Clearly, this factors as x minus 4 times x minus 2. So observing each unique factor in each denominator, we can identify our restricted values. Looking at the first denominator on our left side, if we set that equal to 0 and solve for x, we would get x equals 4. So we know x equals 4 is a restricted value. In addition, from our second fraction, we have the denominator x minus 2. If we set that equal to 0 and solve for x, we can see our second restricted value here is x equals 2. And that covers the restricted values for both factors on the right side. With those in mind, let's go ahead and solve the equation. To solve the equation, we want to clear those fractions, and we're going to do that with the lowest common denominator. Recall that the LCD contains all the unique factors present anywhere in the equation. So the first factor that I'm going to need to represent in my LCD is this first binomial denominator, x minus 4. It's also going to need the factor x minus 2, and notice that covers both factors that we have in the denominator on the right side as well. Once we have the LCD, then we want to multiply every term in the fraction by that LCD. And since every term in our equation is a fraction, let's write the LCD as a fraction. So I'm going to scoot over a little bit here. I think I'm going to need the space. I'm going to take the LCD over 1 times the first fraction, 1 over x minus 4. And I'm going to put that x minus 4 in a set of parentheses. We'll take the same LCD times the second fraction in the equation, and finally the same LCD over 1 times the fraction on the right side of the equation, and I'm going to write that denominator in factored form, so we'll be able to see what cancels. Okay, so every original term in the equation, those are written in green, have received the LCD factor. So I'm going to go back and simplify our products. So let's look at our first product here. There's a common factor of x minus 4, so we'll be able to cancel that out, and notice that leaves behind a denominator of 1. In our second term, we have a common factor of x minus 2. Denominator is gone there as well. And on the right side of our equation, both the x minus 4 and the x minus 2 cancel. So if I look all the way across the equation, all of my denominators have canceled out. So we were successful in clearing the fractions. Let's observe what's left. So in our first product here, we have x minus 2 times 1, which just leaves behind x minus 2. We can go ahead and drop parentheses there. In our second product, we have x minus 4 times the constant 2. I'm going to rearrange that with the 2 on the left side and the x minus 4 on the right side, so the distributive property will feel more natural. And on the right side here, we just have a 2. Once we've cleared fractions, we can observe we took our original rational equation and now we've converted it into an equivalent linear equation. So we know, again, to anticipate one solution, and we can solve this resulting equation by isolating x. As you know, we need to clear grouping symbols with the distributive property. So we'll start there. We have x minus 2 plus 2x minus 8 equals 2. Cleaning house on the left side here by combining like terms, we have 3x minus 10 equals 2. Let's add 10 to both sides to get 3x equals 12, and divide both sides by 3 to get x equals 4. So we did get one solution. Now, alarm bells should be going off in your mind because recall, x equals 4 is a restricted value. So if I try to take that number and plug it back in either to this fraction or the one on the right side, we're going to have an undefined value. We're going to have a 0 in the denominator. So our only proposed solution does not balance the original equation. Keep in mind, it would balance this linear equation, but it does not work for the original equation that we're trying to solve. So this is an extraneous solution. So what's our conclusion? This equation has no solution. Can you believe it? All that hard work for no solution. So again, to solve a rational equation, apply your lowest common denominator to every term and be mindful of those restricted values.